Welcome to the SolidCAM UK Technology Centre and welcome to our latest event. Today we have a selection of partners for you with machine tools, cutting tools, work holding, measuring, simulation, testing, and together we'll be demonstrating how we can collectively show you a total solution for manufacturing and machining. So throughout the event, we'll be using SolidCAM software, showing the various strategies and including our powerful eye machining for fast metal removal. And before I hand you over to Ian and Ben, who will go through the live cutting session, I just want to remind people that we are cutting things live today. So we'd encourage you to ask questions throughout the session and hear the answers that you all want to hear about and things like that. So enjoy the day, don't forget to ask questions, and we'll see you at the next event. Thanks.
Good afternoon, everyone, and welcome to SolidCAM Live here from our workshops in Barnsley for our presentations of live cutting on our ROMI DCM 625X. Today we'll be cutting a live steel part in full simultaneous 5-axis, utilising both our eye machining and 5-axis cam strategies with straight flute and barrel cutters. Joining me today is Ben.
Morning, afternoon, everybody.
And in conjunction with our industry partners, ITC, Shunk, ROMI, CG Tech and Bloom, we're going to spend the next 90 minutes or so attempting to cover as much as we can about our SolidCAM and supporting partners. As you can see, the machine's already running, as there's quite a lot to get through this afternoon. Don't worry, you're not going to miss anything, as Ben's incorporated the earlier footage into his presentation, which is coming up shortly. So let me hand over to Ben, who's going to explain a little bit more about what we've got planned for today.
Yeah, thanks for that, Ian. So as Ian said, you can see the machine's already cutting. So we're in the Technology Centre today, which we've got the ROMI D1000 over at the side there. We've got the DCM 625 axis here cutting. We've also got a lathe that's behind us as well from ROMI. That's the GL240. So like I say, the machine's already cutting. We've just to save a bit of time, but it's doing eye machining at the moment. I've got some pre-recorded footage of this coming up in a demonstration. So just before we flick to the demonstration, I just want to say, if anybody's got any questions, please feel free to use the chat. We'll answer the questions live. If we, for some reason, don't get to your question, please just let us know, and we'll answer those by email at the end. So this tool here is the 12mm bullnose cutter running the eye machining. So I'm just going to give you a presentation first on eye machining, the benefits of eye machining, a little bit of footage from simulation and footage from this pre-recorded bit, and then when we come back we'll continue to watch the footage live, and we'll flick over to some industry partners as well.
So we're first going to have a look at a presentation of SolidCAM. We're going to have a look at the features and benefits of SolidCAM, and we're also going to have a demonstration inside the software as well of the part that's been programmed for today's seminar, how it's been programmed, and then we will cut back to the cameras in the machine to have a look at this being cut live. So SolidCAM are leaders in integrated CAM. The major benefits of using SolidCAM inside SolidWorks are that we have the same look and feel through a seamless single window integration. There is full associativity inside SolidWorks as well. So any model changes that are made will automatically update the toolpaths in SolidCAM. SolidCAM is working inside the SolidWorks assembly mode to define fixtures, tooling and vices, and we've also been gold partners with SolidWorks for the last 17 years. We have a complete integrated solution inside SolidWorks. We are a modular system, so we can add the specific modules needed and when needed as well. So you don't have to have all the modules all at once. If you buy a new machine and need extra modules, these can be plugged in afterwards. Moving on to our iMachining module. So this is our high-speed roughing operation inside SolidCAM with a technology wizard built in as well. So we get increased productivity due to shorter cycle times, up to 70% and more cycle time saving. We dramatically increase the tool life and unmatched hard material machining as well. We see outstanding performance when using small tools, and we can use iMachining on 4-axis machines, 5-axis machines, mill turn machines as well. High programming productivity and a very short learning curve. The unique wizard will optimize the feeds and speeds for you, including the depth of cut based on the stock and the tool material, as well as the machine specifications. So this takes the headache out of programming these high-speed roughing operations. So iMachining comes in 2 stages, all built into the same operation. The first stage of iMachining is to create an intelligent toolpath, so an efficient tangential toolpath, which will ensure constant tool load on the machine. And then the second part of iMachining is the technology wizard. This will calculate the cutting conditions for any given machining operation. So this will calculate things like the speed, the feed, the depth of cut, and also the cutting angles. So we can have variable cutting angles. You can see there from 80 degrees to 10 degrees, we can have set the maximum and minimum cutting angles based on what we wish to achieve, or we can let the wizard handle those maximum and minimum based on the material parameters that it's been given. You can see there on the left-hand side at 20-degree engagement, the feed rate is a lot higher than it is on the right-hand side at 50-degree engagement. So iMachining will fluctuate the feed rate based on its engagement and its contact points as well. Also, the patented unique features inside iMachining are we have the morphing spirals only in iMachining, as you can see there on the left, so with varying width of cut. And on the right hand side, we have intelligent separation as well for iMachining. So we can separate areas with channels to maximize the spiral area. You can see there on the left hand side, we're machining up to a wall. Now, once we're machining up against the wall, we're going to be full engagement with the cutter. So what iMachining does is it separates this section out and machines in a sort of lace strategy here against the wall, and creates these 2 channels here to leave 3 final areas for spiraling. So you can see on this next slide here, we now have the 3 morphing spiral areas that are being machined by iMachining. This is more efficient and better for the tool. So optimal speeds and feeds for iMachining. So the technology wizard will calculate these speeds and feeds for you based on data that we have initially entered. So we would initial the material properties. We obviously select the geometry that we want to machine. We have the tool geometries and we put in the machine parameters. This will then calculate all of these that we see in red here. So the technology wizard will calculate the depth, the feed rate, the step over, and the spindle speed, all synchronized together. Now the depth of cut is calculated inside iMachining, and it is calculated on an optimal depth of cut to reduce vibration. We're looking for an ACP close to a whole number. Now, if you look on the left-hand side here, ACP1, that is one full engagement with the tool. This is minimal vibration. If we look on the right-hand side here, we have many contact points, and we have an ACP of 4.5 as we hit the top, so we have a gap. Now, this will produce vibration based on the fact that the tool has load and there is a flex point at the top here. With this one here, we're in full contact on the left-hand side here. Now, the cutting forces are only now in one direction to the left. On here, an ACP of 3 would be fine as well. So we're looking for an ACP closest to a whole number as we can. And again, iMachining will calculate this for us. iMachining is a patented technology. No other system can use our technology. You may see other systems using the spiral or morphing toolpaths, but you won't see any system using a spiral toolpath and also calculating the speeds and feeds and depths of cut using our technology. So let's have a look at a demonstration of the component that we're actually cutting live on the machine today. So this is the component. As you can see here, this is our setup. And we can see that the component is set up in the vise on the ROMI DCM 620. And we've got the stock in there as well as the part. Now we're going to have a look at the first operation here, which is the iMachining. So this is using the 12mm bullnose cutter with a 1mm rad on. You can see the target has been picked. The stock definition is automatic. We can see the tool here. So this is the 12mm tool from ITC, 4mm rad. And on the iMachining data, we have told it that we're cutting EN24T. This is a premium carbide and the helix angle is 36.5. Now, if we have a look at the technology wizard, this is the ACP here. You can see how it's highlighted in green. So we have an ACP of 2.19, which will minimize vibration. You can see here the speed, so the meters a minute, we're running at 183. And we can also see that in the feed rate as well. So the maximum feed rate of this toolpath is going to be 5,261 with a step over of 0.5. Now, the machining level can be adjusted depending on the rigidity of your setup and the application that you're using iMachining for. You can see as we slide the bar for the aggressiveness that the speed and feed will change in tandem. This is the tool path. So this tool is roughing halfway down the component. So to minimize the tool stick out, we've got the 5-axis machine. So we're roughing halfway down and then we will tip over and rough the rest at an angle. Those two operations there are just finishing the ends of the wings just while we've got the rigidity in the component and to stop the vibration. So this is the second iMachining toolpath. You can see this is done from the nearly 90 degrees. It's about 85-degree angle. Again, the ACP 2.15, so we're in the green. The technology wizard will tell you if you're going to get vibration. You will go into the orange area, which means that there is likely going to be vibration. And then we'll move into the red, where we will get vibration. As you saw in the presentation, we're using varying cutting angles, which will vary the speed and feed. You can see here that automatically the angles have been selected, which means the required power at the motor is 2.2 kilowatts. Now, if I change the max cutting angle to 20 degrees, for instance, you can see the power required at the motor is now 1.8 and the feed rate has adjusted. So the maximum feed rate has gone up, but the step over has come down. So again, I'm going to unselect that and leave that as it was and let the technology wizard pick the best suitable cutting angle for this tool. Now if we have a look at the next operation, so the next operation is then from the other angle, and then the other two eye machining, or the other four, should I say, eye machining operations are with the 8mm bullnose end mill from ITC. So again, all the eye machining data has been selected. We're also using a scallop at this point here, so we're rest roughing as well. So we're going full depth of cut with eye machining, and then we're asking it to go back over the component, leaving a 1mm scallop all over in order to give us a rough shape ready for finishing. So you can see those 4 toolpaths on there. I also want to show you the next toolpath as well, which is not a roughing toolpath, but I'm using it to rough the bottom shape of this component out. So I've actually used a 5-axis simultaneous operation here to rough this plinth using the radius on the side of that 12mm cutter. So I've selected these 4 faces around the component to machine using parallel cuts, and I've told it a drive offset or drive surface offset of 0.25. If I go and have a look at the strategy, you can see I've selected it to be output in 4-axis mode only, and I've locked the 5th axis at 65 degrees. So I've actually locked the B axis over at 65 degrees, and then we're going to rotate the C axis around. So you can see there, this is the angle of the cutter. So I'm getting contact on the radius here, and I'm just taking cuts all the way around here to rough that to within 0.25, ready for finishing. So that's just to show you there that there's always more than one way to rough an area on a component. So if we have a look at the simulation here, and you can see the live cutting of this job as well. So you can see the simulation shows us what we're cutting on the machine. Now this is eye machining, this is that top component there. Now this is full speed as well, this has not been sped up. The simulation obviously is a little faster than the actual machine cutting, but we can see here it's machining away all of that material. It's using the full flute length, so we're at about 22mm depth of cut here. And what you'll see next as well is the scallop that we put on there. So I told it to leave a 1mm scallop, so you can see it's done all its full depth of cut first, maximizing that tool efficiency, and then it's gone back over the component to do its 1mm depth of cut. And you can see on the left hand side here it's in cut, in eye machining. So again, full depth of cut now on this second cut. You can see it actually working there on the machine, and the simulation's moved on to the other side. It's a little bit in front there. If we have a look at a little bit of slow motion here on that back side of that component, you can see eye machining there, peeling the material away. So this is a small step over, high speed and feed with a full depth of cut. And this is now over, tipped over, so we're roughing out underneath those wings of this component. You can see we're still using the eye machining technology to rough that area out. You can see here, this is the plinth roughing here. So this is where we used the 5-axis simultaneous to actually produce a roughing cut. So 5-axis can be used for roughing just as well as it can be used for any finishing cuts as well. What we're going to do is we're going to come back to the machine now and go back to the live demonstration, and you'll be able to see this cutting live as it is doing here in this recording.
Yeah, so as you can see in the presentation, it's running all that eye machining there. You can see the live video feed now. You should be able to see that on your screens. You can see it's doing that roughing around that plinth as I showed you with that 5-axis operation. So we've done all the work with the 12mm tool there, roughing out all of that area. We've had a couple of questions come in as well throughout that presentation. One was, is eye machining beneficial on aluminium? Yes, it is. It's beneficial on any material that you use. So you get greater time savings on a harder material such as titanium, but you still see savings on aluminium as well. Another question coming in there, how much time does eye machining save compared to other machining strategies? So we boast 70% cycle time savings, but as I said, in the softer materials, you're looking more down the sort of 50% mark and going right up to about 90% when we get up to the harder materials like titanium, Inconel and things like that. So that's the 12mm cutter finished there. So now it's going to move on to the 8mm cutter. So we're going to do some more eye machining with this, as you saw in the presentation. This is going to be nibbling out the bits that the 12mm cutter couldn't get to. So this is ITC's 8mm cutter. You can see it's banked right over there now. We can get right down into those areas and cut those out. Any more questions? So this cutter as well, this is the 12mm cutter, was running at a maximum feed rate of 5,261 with a step over of 0.7 at a full depth of cut of 22 millimeters, so just over 22 millimeters. This cutter here is running at a maximum feed rate of 7,156 with a 0.25 step over, and again at 22.8 mil depth of cut.
I've got a question here, Ben. Somebody said, is this operation what they class as rest roughing?
Yeah, so this is, it's not what we would call rest roughing in the software. We're not looking for an option called rest roughing, but because eye machining is fully stock aware, we just tell the 8mm cutter to now cut the parts against the remaining stock. So the 12mm cutter's been in there, the software knows what material's left, and the 8mm goes in there and cuts all that away.
Okay, we've got a question about what the material is that we're cutting. I said it was steel, but I didn't actually specify exactly what it is.
Yeah, so we're cutting the N24T today. So quite a tough material that we're cutting. We're cutting it at about 180 meters a minute with these two tools on the eye machining. We've also got another question coming in there as well. It shows the area of vibration. Will it give you a recommendation to reduce the vibration? It doesn't sort of give you a recommendation as such. You can see by the ACP value what you're sort of looking to adjust. Adjusting the helix angle on the tool will greatly improve the ACP. You can also adjust the depth of cut as well if you wish. So you could send the tool a little bit deeper or a little bit shallower. It will change the ACP.
Okay, there's a question here about the integration of SolidCAM with SolidWorks, and are there any particular benefits from using this integrated solution?
Yeah, so SolidCAM being inside SolidWorks means that you've got a seamless integration between the two bits of software. So we don't need to move from CAD and from CAM. We don't need to be reloading a CAD model or anything. Any changes made in the CAD software, so any changes made in SolidWorks are reflected then in the operation calculations in SolidCAM. It's also one of the world leading 3D CAD packages. So it's what a lot of people use. People are already familiar with. The look and feel of SolidCAM is the same as SolidWorks. So we follow the same sort of user interfaces. It's all sort of a seamless transition from one to the other.
Okay. Just going back to the eye machining, there's a question here about why we're cutting it dry rather than cutting it with coolant.
So one reason we're cutting it dry is for the cameras. The other reason we're cutting it dry is because we don't really need the coolant on this particular job. So if we were in a softer material, then we'd probably be running the coolant. Harder material, again, we'd be running the coolant. Again, sometimes on a material like EN24T, we may run coolant if we're down in a deep pocket where we want to sort of get rid of the swarf, so we're not chewing the swarf up and damaging the tool. In this instance, the swarf's falling away quite nicely, and I'm also running air on the machine as well, so the air blast is blasting the swarf away from the tool, trying to keep the heat inside the tool and the material as well. Now, these two tools, well, all of the tools that we're using today, but these two tools that you've seen already have been supplied by ITC. So we're just going to have a quick interview from ITC and a bit of a presentation on what they do and what they can supply.
Hi Jason, thank you very much for joining us today. Really appreciate the support of ITC in this live project. And again, thanks for letting us have the tooling as well. Obviously, we couldn't do it without that. Obviously, we decided what size cutters we're going to use, but you've kind of told us what the tools need to be geometry-wise. Can you tell us why you chose those particular tools?
Yeah, I mean, obviously we've been deciding what methods he was going to use on the live demo, barrel cutting and the trachoidal. I went for the 5021 series, which is predominantly designed for trachoidal milling anyway. We've got a full range of tools that we developed for that. This particular tool is 5 flutes, variable helix, variable pitch, and a coating on. So it's designed specifically for doing that type of milling. Also, we've got another range with chip breakers in now as well, specifically designed for getting rid of swarf where you're using full flute.
Got you.
And then obviously we've supplied the back end tooling as well. Yeah. So this is a very important part of it when we need to make sure the tooling's running very true. So yeah, that's why we've gone with those particular tools. The barrel tool was designed predominantly by Ben, relating to the shape of the part. So then we've gone with that drawing and manufactured that to suit.
Yeah.
So that's it really.
Yeah, I mean, I'll bring us on to another part, I suppose. I mean, ITC, one of the leading manufacturers in carbide tooling. How have you guys developed your manufacturing base?
Well, we've invested heavily in machines over the last few years, and we've got the latest technology available to us now, so we can compete with anybody in the marketplace. With that, we've got 30 CNC grinding machines, right, capable of going from 0.2 to 40 mil in diameter. We've got new blanking machines that have enabled us to cut out the pinch points in manufacturing. Also, we've got a new diamond wheel grinding and balancing machine, which has obviously cut our times down and saved us costs on the wheels, increased the wheel life for us as well. So those are some of the improvements we've made, along with replacing the older machines with new ones and new technology. And we've recently just released a new app, which is available on Android and iPhone, which enables customers now to purchase direct from the app. Right. So yeah, we're trying to keep up with everything. You know?
Yeah. I mean, obviously, we believe SolidCAM is one of the best CAM software solutions out there, and we could have used, you know, numerous solid carbide providers. Why do you think we should have chosen ITC?
Well, I think the thing is about ITC is we're a solution-based company, not just a manufacturer. We've got engineers, sales engineers that work all over the country, and they're all from a shop floor background. So they're all capable of standing with the operators on the machines and doing the job. And that's a big part of it. You know, it's all about the solution as well. And we've also got a team in the office that can answer questions, technical questions as well. So it's one of the biggest parts of it is obviously making sure that you can cut time out of the job, because it's not just about the price of the carbide. You need to be able to offer a solution where you need to be able to look at what the customer's doing and how he's using that tool, the methods the whole package, rather than just saying, look, it is an end mill, because that's the whole point of it. We've got to be able to reduce those costs, and it's not just by the tool, it's by the methods and offering a solution.
You mentioned it previously about the importance of tool holders. Can you just explain that a little bit further for us?
Yeah, the tool holder side of it is a very big part of the whole package. You've obviously got a very expensive machine, really good quality tools, and you want to put the interface between them in the middle of it and make it work really, really well. Yeah. Now, there's a lot of cheap stuff on the market. You know, there's a place for everything, but some of the cheaper end collets will have a 15 micron run out, and that makes the tool oscillate rather than run on its center, which has an effect on each flute cutting properly with on the job, and that affects tool life, surface finish, vibration, everything. So if you put a good back end quality tool in there, like the
Cool. At the moment, most customers want as few suppliers as possible. So other than your own products and spindle tool, is there anything else that ITC offers?
Yeah, we currently are the UK distributors for Whittier products, where we have the indexable tooling inserts, we have lathe tooling. As I said, we supply the big Kaiser product, which includes the back end tooling, boring bar systems, again, tooling for lathes, milling machines. So we've got a very wide range of products along with the ITC products as well. We also are the UK distributor for bass taps as well, although we do have our own program for thread milling and taps. So yeah, again, the big Kaiser stuff, the boring equipment that they do is fantastic. We've had some really good results with that. There's a new automatic adjusting boring system that hopefully we want to demonstrate with you guys at SolidCAM later this year. So
yeah, I'm sure that's something we can do at a later date. That's fantastic. I mean, you know, some really great information in there. It just really leaves me to thank you again for the support during this event. You know, it's been possible to do it without the technical partners. So just for now, Jason, just thanks very much again, and we'll catch up with you soon.
Yeah, cheers, Ian.
Thanks for that, Jason. It was great to catch up with you. Some great stuff coming out of ITC, and obviously the fact that they're manufacturing the tools specifically made life easier for us, because obviously Ben designed the barrel tool that we're going to use later on, and they just manufactured it to our spec. We're still machining, so I'll just pass back over to Ben.
Yeah, so the eye machining, so going to still the 8mm, picking out the corners at the bottom. A few questions coming in while we were watching that little presentation there, as well as does eye machining work in full 4 and 5 axis simultaneous? No, it works in 3+2, as you can see here. So we come over to an angle and we work in 3 axis. We do in SolidCAM have a 5 axis simultaneous roughing strategy, which is like a morphing toolpath, or you can do concentric toolpath in there. What is the milling chuck in use? So these are Kaiser back ends from ITC. You heard him speak about those. Jason speak about those in the presentation as well. And then we've got as well, does SolidCAM also integrate with SolidWorks' big brother CATIA? It doesn't, but we have iMachining does plug into NX, and we also have InventorCAM as well, which is SolidCAM inside Inventor. So that we've got those options there as well. Any more questions come from your side, Ian?
Nothing else here at the moment. No.
Does the software allow for rendering working scaled models? So yeah, we can scale a model inside CAD. So inside SolidWorks, we can scale the model and then just work off that model. So you can create a larger part or a smaller part depending on what we're doing. You can see the 8mm tool there still working away. We've got a little bit more picking out to do on there with that tool, and then we'll be moving over to the barrel tool where we'll be finishing those wings, and we'll be finishing the floors and everywhere else with that barrel tool as well. Just have a look for some more questions on here. What is the work holding being used? So the work holding on here is the shunt system. Again, we'll have a little presentation from Marcel at Shunt shortly. So he'll be showing you all about the Vero West system that we're using here. So it's the quick change 0-point setting system. We've got the vise in there at the minute, but if you watched our last live presentation, you'll have seen it with the vise in there and with the diaphragm in there as well. So the diaphragm that clamps the part down to any shape that you've created.
Is there any chance we could demonstrate full 5-axis morphing past roughing? Probably not right at the moment.
No, so we can, if you want to contact us, or I've got your question now, we've got your contact details, we'll contact you about doing a demonstration for that, so we can demonstrate the full 5-axis morphing toolpaths in SolidCAM. There is going to be a presentation shortly on simultaneous 5-axis in terms of finishing. So I'm going to show you how I've programmed the simultaneous toolpaths on this component here, and how we're doing all the finishing with that barrel cutter.
And do you want to have a quick discussion about the machine that we're using?
Yeah, so the machine we're using is the ROMI DCM 625X. So it's the 5-axis simultaneous version of their 5-axis machine. So they have a 5F and a 5X. So let's have a presentation now from ROMI. So this is John from ROMI. He's going to tell us all about ROMI and their machine tools on there.
Hi there, John. Thanks for joining us today. Obviously, industry partners are very important to us, and ROMI as a company play a huge part in what we do at SolidCAM in our workshop. Would it be possible if you could just give us a bit of an introduction as to ROMI as a company?
Sure. Well, thanks for having us. We appreciate the relationship. Okay, for those that don't know, ROMI are a global machine tool manufacturer and supplier with several production facilities in Brazil, along with our own castings foundry and subsidiaries across UK and Europe. The business comprises of roughly 3 divisions, the first being ROMI Machines, which encompasses vertical machining centres, horizontal machining centres, turning centres, and our combination tool room CNC lathes. Also our plastic injection moulding machines, which is an increasing business for us. Secondly would be Burkhardt and Weber, which are a manufacturer based in Germany that we bought some years ago, that manufacture very large, high precision and sometimes customized machines, largely for sort of power and energy industries and sectors such as that. And the third is our rough and machine castings, cast iron parts facility, which is part of our castings foundry.
Okay, that's great. Obviously, everybody's been impacted over the past 3 months with the coronavirus. How has ROMI fared as a company, and how has it affected you?
Well, from the Brazilian perspective, at the moment, it's it's odd really, because in the last quarter of 2019, it was a substantial increase on the year before, and fully expected the coronavirus to really put a big dent in that. But thus far, it really hasn't. The Brazilians are quite a bit more affected than we are, but they haven't seen the impact of that on the bottom line as yet. In the UK, from a personal perspective, absolute roller coaster it's been. Yeah. From the initial impact and the fear surrounding the whole industry in the UK, to a sudden influx of short-term inquiries, which has resulted in a number of orders, possibly more in the last month than we had in the first 2 or 3 months of this year. So I can't say exactly why that's happened, but it's a testament to our customers and UK manufacturing as a whole that they're prepared to make these investments.
Absolutely. I mean, we've kind of noticed the roller coaster you just mentioned in there. Obviously, we're quite keen to work with industry partners and gain the benefits of those different marketplaces. How do you kind of find working with SolidCAM as a partner? What do you get out of that?
Well, firstly, I mean, from a completely selfish perspective, it's a second showroom for us. We're obviously based in Rugby, and right in the middle of the country. So to have a showroom in the north is invaluable. With an increasing array of machine tools, from small tool room lathes to the CNC turning centres, right up to your brand new 5-axis machine. So from that perspective, it's invaluable. But also the events that you put on, we try and emulate ourselves. Far more centred around the sharing of knowledge between us as a machine tool supplier, the software that goes with it, the CAD and CAM, along with tooling suppliers and metrology partners. SolidCAM do an excellent job really of not only for customers as such, but people who are just interested in the business and in kind of afflicted with that engineering nerdy side. They come away from it, knowing a lot more than they went in.
Yeah, absolutely. I find that being able to work with industry partners allows us to offer a greater scope of knowledge, and the collaboration that we're able to offer makes it invaluable to, like you say, just prospects and people who are just interested in engineering. Yeah, John, it's fantastic. Thank you very much for joining us. It's been absolutely brilliant. Obviously, we're looking forward to the continued relationship with Romy. And we've got a second event coming up after this one, which again I know you guys are involved with. So we do really appreciate your support. But for now, thank you very much, John. That's brilliant.
Thanks, man.
Thanks for that, John. Good to talk to you, and very interesting, the information about the manufacturing plants and everything that you have in Brazil. We see the machine tools, but we don't always appreciate what it takes to manufacture them. Okay, we're now starting with the barrel cutting, so I'll hand you back over to Ben.
Yeah, so as you can see, the machine's running the barrel cutter now. This is its first bit. You saw it just went and picked out the radius at the bottom of the wing there. Now this barrel cutter's got a 100mm radius on the side of the cutter with a 1.5mm blend radius down to the bottom. So effectively got a 3mm ball nose at the bottom. So I'm using this tool as a ball nose, and I'm using it as a barrel cutter as well. So I picked out the rad at the bottom just to take the meat and the weight out of it there. There is 0.5 left on all over this component for finishing. So this first cut with a barrel cutter here is cutting it to within 0.1, and then it's going to go back over that wing and just give it a nice 0.1 finish cut, just to give it a nice finish on there. Question coming, how did you select the specific radius for this application? So in this case, all the shape of this component is external shape. So the radius really is not too critical. I picked 100 mil radius. It fits against all these side walls. If we had internal shapes like pockets and things like that, then the radius is a bit more critical because we need to fit into corners. We need to fit into internal shapes on 3D profiles and things like that. So that's how we would sort of look at the barrel cutter.
We have another question here. Can we explain what the benefits of using a barrel cutter are?
Yeah, so the benefits of using a barrel cutter against using a ball nose are the time savings from having a larger step over. So using a ball nose to get the surface finish that we're achieving here today, we'll be using around about a 0.1 millimeter step over with a ball nose to get this surface finish. Now with this barrel tool, I'm actually doing a 2.5 millimeter step over on these wings to achieve that same surface finish. So going from 0.1 to 2.5 step over, that is a massive time saving before you've even looked at changing the speeds and feeds. You've got the rigidity in the tool. And all this is down to having that large radius on the side of the barrel.
We've got a question is, how well do the barrel cutters work when you're swarf cutting?
The barrel tools are designed really for this type of work, for doing this swarf cutting. Now we're climb milling here as well. So like on a ball nose, you would probably be going zigzag, because if you're on the bottom of the ball, you need a climb or conventional cutting. If you was to tip over, then you would probably respect the climb milling. With this, we're using the side of a cutter. So even though it's a barrel cutter, it's still got flutes down the side wall. So we're always climb milling with these cutters to give us that nice finish. We don't want to be conventional cutting on here either. Now, like I said earlier, there's a presentation coming up as well on 5-axis. So I'm going to show you how I program these wings. I'm going to show you how I program the floor as well using that barrel cutter. And I'm also, like I said, using the ball of the barrel to actually scan the body of this component as well. So it's an all-in-one tool. We're only using 5 tools on this job completely. So 2 are the end mills that you've already seen. Then the third one is this barrel tool here, and then we've got a 6 mil chamfer tool and a 1.5 mil ball nose for engraving. So actually, if we take the chamfering out on the ball nose, we're putting this part here with 3 tools to get these surface finishes on here. Now, before we go to sort of seeing a bit more barrel and having a look at the 5-axis inside SolidCAM, I'm just going to pass over to Mark Stocks, who's going to give us a presentation on the Swiss type capabilities inside SolidCAM. So we're going to have a look at how we can support the sliding head and Swiss type machines and all the benefits that brings to us inside SolidCAM.
SolidCAM support for Swiss turn is both comprehensive and simple to use. In this overview, we will be demonstrating this on a Citizen M32 machine. This machine is a 3-channel machine with 5-axis capabilities, multiple machining patterns and superimposition. All of these features are fully supported in SolidCAM with full machine simulation. SolidCAM supports all tool holder types, including multi-station tool holders for both milling and turning tools. Tools can be moved to different stations and dynamically viewed to make sure the tools are set to the optimum position. Programming of operations is exactly the same as it would be for any mill turn machine in SolidCAM. Here we are selecting the area to turn directly from the model and the tool from the library. The toolpath is then calculated with full support of cycles on the machine. As with all operations, this can be viewed and simulated as the machine will cut it. Even adding more complex machining strategies such as cylindrical milling is kept simple. Select the area to machine direct from the model, the tool, and SolidCAM does the rest. Once the programming is complete, the channels can be optimized to get the best cycle time on the machine. Currently, the part is programmed as a single part, but in reality, we want to be working simultaneously on both spindles. This is done by selecting the operation to start machining on the second spindle. Now we can see the operations working together in all three channels. Based on this, SolidCAM will automatically choose appropriate machining patterns which can be reviewed and changed by the programmer, as in some cases alternate patterns are available. The programmer has full control over the positioning of the weight codes, and SolidCAM will assist this by dynamically checking and advising any issues. Now the complete program can be simulated as it will be cut on the machine with all axes working together. This highlights any potential collisions and will show any superimposition moves programmed, giving confidence the program is correct before being passed the machine. This can significantly reduce machine downtime. Once this has been proven successfully, the G-code can be created in a single click. And here we see the result displayed in our SyncMaster software, clearly displaying weight marks and axis patterns. SolidCAM is available for all Swiss machines. For more information, please go to solidcam.com.
Thanks for that, Mark. Yeah, a real good demonstration there of what SolidCAM's capable of when it comes to these complex advanced build turns and Swiss type lathes. Just before I talk about that a bit more, as some of you are experiencing some sound and video quality issues, we do apologise for that. We've got quite a lot of people on the stream at the moment, so I don't know if that's affecting the output. So yeah, with regards to the Swiss type and the advanced mill turn, just moving on to services in terms of post-processors in general and training and support is all done from this technology centre here. So the applications team all work from this Barnsley office here. We all deliver the support, training and post-processors from the UK. So anything needed in terms of post is all done from here. The support is direct. In terms of Swiss type, again, that is the same. It's all done here in the UK, and we have a dedicated team now of post-processor engineers just for Swiss type. So we all do post-processors, like I say, but we have dedicated people that are just doing Swiss type to gain that valuable experience needed for those style of machines. Do we have any more questions?
Yeah, we've got a question in going back to the barrel cutters. Somebody's asking, can you explain the different strategies for the different types of barrel cutters? Because obviously there's barrel and lens type cutters, aren't there?
Yeah, so we obviously you've seen that the standard barrel cutters, as people would first think of when you say barrel cutter, is the radius on the edge of the cutter. You've also got lens cutters, so we can use we can have a large radius on the bottom of a tool, and we can use that in 3-axis as well as 5-axis. So we can use that for surface scanning on 3-axis 3D shapes to get the same effect. So it's a larger step over, creating that same surface finish. We've got another question here as well. Can I simulate a program, a SolidCAM program on the machine control? So yes, the SolidCAM produces G-code in either Heidenhain, Siemens, Fanuc, whatever your machine control is, we can output that code. And then that code is just read by the machine like any other program. So you can have the simulation on here. In terms of this machine here from Romy, the Siemens 840D, you can define the stock size. You can have 3D simulation of the tools cut in the stock before you run the program. So as well as the SolidCAM simulation, you've also got secondary simulation at the machine.
Okay, there's a question here about do we provide within our software the ability to create or edit the post-processors?
Yes, so the post-processors that we write, a user with experience could write the post-processor if they so wished. Obviously, there's lots of things in there. Our experience in there obviously means that we can write it more quickly, more efficiently, and also we know what we're looking for and where we need to be looking at the output and things like that. So yes, you could write your own post processor. It wouldn't be recommended from our point of view. when we write a post processor, we would check the code, we would come on site, we would test the code as well at the machine with you. So it's always best to get that experience and expertise to have us write it for you.
Okay. Would you like to just explain a little bit about the work holding? Obviously, we're using Shunk as a partner for the work holding, so we've got their vice mounted on the Vero S point. Can you just explain a bit about that?
Yeah, so as I said before, we've got the Vero S double pot system on this machine. You can see it there. Now it's tipped over just underneath the vice. 2 pots. So this is the 0 point setting double pot system. And then the vice sits on top of that. So it's pretty accurate putting it back in the pots. It's to minimize setup times. You can take the vice off. You can have 2 vices. So basically you're setting 1 vice outside of the machine. As soon as this machine is finished, we could take this vice off, drop the new one on with a new setup on it, and just hit go. So the setup time is then minimized. You're maximizing the time that the machine is running, rather than doing a setup in the machine and then having the machine down for half an hour while you put a new block in. Now this is the 8mm tool just come back in. It's just going to go finish that tail pin on there, so you can just see it going round. Now talking about the Shunk vice, just going to have a quick presentation from Marcel at Shunk, and then when we come back we'll see this barrel cutting finishing off the floors at the bottom there as well.
Hi Marcel, thank you very much for joining us. Obviously we're very pleased that you continue to support SolidCAM with your products. We're currently using your 0 point system on the 5-axis machine. Could you tell us a bit more about the 0 point system?
Hi, and thanks for having us. It's a pleasure to be part of this project and these webinars. So yeah, on the 0 points, I think, first of all, it's one of the best kept secrets in the industry. It's amazing how little is used in UK. We see a lot of usage of 0 point systems in Germany, and it's something that for us is a no-brainer. So essentially, the 0 points, it's a setup killer, right? So you can externalize your setup or do it everything offline. So you would have a space for you to work outside the machine. So while the machine is working, you will preset your next job. Then you could, as soon as the machine stops, you can just release the air, add air into the 0 point system. That will release the part, you take it out, drop it in again, and the changeover is done within seconds, 5 to 10 seconds stops. So that it's, no matter how people tend to think of the 0 point as, oh, but I need to have a lot of production or a serialized type of production. I do lots of one-offs. That doesn't really suit me. Actually, it's quite the opposite. The more changeovers you have to have, no matter if they are the same job or different jobs, the more the 0 point will assist you. Right. And in terms of precision, we're using these now today on this presentation for aerospace. The repeatability and the precision of the 0 point is second to none. So our system offers a repeatability of 3 microns. Right. So it's really set it and forget it kind of system. You know, it's a suit every single application kind of solution.
Right. Okay. And obviously we're using the 0 point on the 5-axis, and on top of that we're using one of your vices as well. Can you just tell us a little bit more about the types of vices and a bit more about them, please?
Yeah, we have a complete range of vices. Today we're using a mechanical vice, which you could think, well, what's the difference in mechanical vices? They're all the same, right? So let's just get the cheapest one. Not quite. So our vice, it's fully shielded. The mechanism we use prevents any kind of sort of contamination inside the vice. So again, that saves a lot on the setup. You don't have to clean the vice every now and again. You will never have a problem in terms of sort of thing. The other point is every single mechanical system has a tolerance, a variance. So, you know, you clamp the thing, so the part will either swing each way.
Okay.
Most of the devices out there, if not all of them, that tolerance can be variable to one or other side of the device. Our device has a consistent variation to one side. So although it does have a tolerance, that is absolutely repeatable. So you can accommodate that on your process and eliminate any variance on your process. That is incredibly important when you're doing something as precise as what we're doing here today.
Okay. I mean, just going back to your point about the single point fittings, I think one of the questions that has been asked is how much pressure do you need to actually release the clamps within the single point? There isn't that much requirement in the way of air pressure, is there?
It runs on a 6-bar system, so it's normally the system you already have installed with any CNC machine. It's available to every CNC machine. So, and it's another important point to bring up now is that it doesn't operate while it's energized. So you need to bring the air to release the system.
Yeah.
Air to unlock. So you just have a normal 6-bar line system around your machine. You bring a pipe, connect that to the system. That will unlock it. You take the part out. You drop the new part on, pull the pipe out of the system, and it's locked in again.
Yeah.
And so no matter what happens, the part is always going to stay in place.
Yeah. I mean, obviously we've been using it for quite a while, and one of the things I did notice, and I think we brought this up at the last seminar, was that if you want to make sure you get a good hold of it, it automatically clamps as soon as you release the air. There is also a secondary clamping so that you can actually push air behind the clamps as well, isn't there?
Yeah, so the turbo system it's a clever valve system. So the standard one will give you plenty of clamping force, but you can up that to 48 kilonewton with the turbo system, which is again is just doubling the air system, and again it doesn't need to be energized. So yes, it will turn to the system, will lock itself in position, and once the air comes out, it's locked in with the extra pressure on it.
Yeah. That's absolutely brilliant. I mean, like I say, we use it all the time, and we find it's a fantastic system. So I'm very grateful for you to spend the time with us this morning. You know, I'm sure that the event's going to be a great success, and that's partly down to the partners that we're dealing with. So once again, thank you very much, Marcel, and look forward to catching up with you soon.
Brilliant.
Thanks for that, Marcel. That's interesting about the automation and you know, the robotization of the process. That kind of adds another dimension to it. Just while the machine's still running, as you can see, just wanted to sort of have a quick mention about one of our other products, which is HSM, high-speed machining. This incorporates high-speed roughing and high-speed finishing. It's predominantly aimed at the mold and die industry because of the machining strategies, and it works particularly well direct from the model. And there's about 20 strategies in there which allow us to sort of finish in multiple ways. So we've got raster machining or vector machining and waterlining and pencil milling, etc. So as a product, it's really beneficial to be able to add that to the strategy, such as the Swiss style and the 5-axis. We've also got the ability to do steep and shallow machining. So just by giving it a contact angle, we don't need to work out any boundaries, and the system will automatically work out from it where it needs to switch between steep and shallow machining. So it's you know, a cracking product, and you know, something that's added to the stable of products we've already got. We've got other options as well. I mean, Ben, would you like to sort of talk about one of the things that is a bit of a hot topic, which is mirroring in multi-axis?
Yeah, so we have full mirror machining inside SolidCAM. You see this part here is well suited to mirroring. So we can mirror on one single part, or we can mirror an entire part to create a left and right hand handed component. So on this particular job, you see the wings. When I barreled around those wings, and when this finish in here, actually at the bottom, at this point here, this is using the ball nose. It's already finished that wall down the side with the side of the tool. Now it's using the tool as a ball nose cutter to actually scan that body on there. So what I did here is I just programmed one side of this job and then simply hit the mirror button and mirrored it about the plane and got the other side machined within a matter of seconds. Now that is going to be in my presentation, which is coming up shortly. So I'm going to show you the barrel milling, how I put the toolpaths down. I'm going to show you the mirror machining capabilities on there as well. So I'm going to show you the presentation. The mirror machining, I show it just on one operation, but just to elaborate on it, you can select multiple operations at once and hit mirror and mirror all those jointly, which is what I did for this component here. So while that's just still running, it's just scanning that body. You can see it's just lifted now. It's just turned over and just going to pick that radius out in the bottom. So at that point there, it's done all that work on that side. It's finished that side. And this is the point now where we spin around, and now we're doing the other side of the component. So this is the mirrored section now. This is the mirrored part of that component. So let's have a look at the presentation and how I've put these toolpaths down. Then when we come back, we'll continue to see the barrel cutter working.
This is a component that you can see cutting live today. You see in the previous presentation we showed eye machining, roughing all this area out. I want to show you the 5-axis simultaneous operation inside SolidCAM that we've used to finish machine this component. So the first thing I'm going to be looking at is this wing profile here. So how we finished this wing with the barrel tool. So I'm using the 5-axis simultaneous milling operation from SolidCAM. I'm using the morph between two boundary curves in this particular operation. I've selected these surfaces as my drive surface. My first edge curve is the top of the wing, and my second edge curve is the bottom of the wing. If we have a look at the step down, you can see I have a 2.5mm step down on this operation. And to show the tool with that step down, we have the barrel tool from ITC, which is the 100 radius barrel shape with a 1.5mm radius at the bottom. So effectively a 3mm ball nose at the bottom. So if I simulate this operation for you, you'll be able to see the tool finishing that wing. So full contact with the barrel tool. Now I've used that barrel tool quite a lot for the finishing, well, mainly for all of the finishing on this part here. The next one I want to show you is the floor. So finishing the floor with that barrel tool as well. So for the purpose of access, getting under there with a flat tool or an end mill using the side and swarfing it or profiling that from the side, you would have to have the table at 90 degrees, meaning that there's a chance then that the table is going to collide with the head. So to keep the tool tilted, we're using a barrel tool again. This time again, I'm using the simultaneous 5-axis operation, and this time I'm using the parallel to curve strategy. So this time I've selected this floor here, and then I've selected this curve to drive along. Again, the same step down, or 2.3mm step down this time instead of 2.5. And on the tool axis control, I'm actually controlling the contact point of the barrel cutter. So instead of tilting at one fixed angle and contacting in the same place on the barrel profile, what I'm doing is changed the contact point to barrel section, and between 30% and 0% up the barrel profile. So you can see here the little image there. So 0% being at the bottom of the barrel profile and 100% being at the top. So as we simulate this, if we have a look on the side view so that you can see the contact, you can see there that the contact on the barrel is up at that 30% mark where I've set it in the operation. If we just speed that up so that we go down that profile, and again you'll notice that it's going in one direction, so we are climb milling with this barrel cutter. Now if we look at the contact point now, as we go further down, you can see the contact point has changed. So now we're down further down the barrel section, and by the time we get to the bottom, we'll see it at the 0 contact position, which is right on the end of that barrel section. So again, even though this is an oval form tool or a radius tool on the outside there, we still need to respect the climb milling direction. Now, another operation on here is using a barrel tool is finishing this simple flat face here. Now again, for the purpose of access and being able to tip the tool, finishing this with the barrel tool. And if I have a look at this strategy, so this is now the, again, 5-axis simultaneous milling operation. This time I've chosen parallel cuts, which means I only need to select a face to cut. So I've selected this one face, no other selections have been made. And again, the same applies. We're using the barrel section and we're altering the contact point as we go down that profile. Again, not only does that mean we get a greater tilt as we go down, we're also having even wear along that barrel section. So instead of just using one contact point all the time and wearing one area of the tool, we're using the full profile of that tool. Now, moving on to mirror machining. So I'm going to show you this on a 5-axis toolpath. So for instance, the wings on here. So we've done one wing, and as you can see, I've got an operation here that does wing number 2. Now the way that I created this operation, wing number 2, is simply by right-clicking and mirror, and a new operation mirrored about the ZX plane and use the same coordinate system. Okay, that it will recalculate the toolpath, and I now have a second toolpath that I can simply go in and rename as my wing 2 toolpath. So that's how easy the SolidCAM mirror function is. That can be applied on any operation. You can see here I have the profiling of the end of the wing, and notice that we are climb milling. So we start, this is the red dot is always the start position of the tool. So we start at this side and we climb mill along that wing profile. And to show you, if I mirror this operation again about the ZX, you'll see that the climb milling direction is respected automatically. So we now start at this side of the wing and we climb mill up the end.
Yeah, so that was the presentation regarding simultaneous 5-axis. Question come through just as I was explaining that presentation there as well regarding, does mirror toolpath respect climb milling? So as you saw there, yes, it does respect the climb milling direction. Don't need to do anything, don't need to go in and edit the operation. It will just climb mill on the mirrored toolpath, so it respect the same direction. As well as mirror toolpath as well, we have got optimized translation functions as well, so you can translate in the X and Y. We can rotate around 4 axes. Same on a lathe with live tooling on a C-axis. We can machine at one point on the C-axis, and then we can simply just repeat that around the diameter quite easily and quite quickly, as you've just seen there, with the same functionality as that mirror toolpath there as well. So anything else you want to add at this point?
No, I was just gonna kind of go on to one of our other partners, Bloom, who do the on-machine inspection, and just maybe talk a little bit about that just before we go into their presentation.
Yeah, so we obviously partners with Bloom. You may have seen on the last event that we held, we've got the Bloom probing systems on these machines. We've got a presentation on that as well. So I've got some pre-recorded footage of the Bloom probe in action on our machine. It's doing some inspection of a job we did previously, and we're going to. I'll flick over to that presentation now, and then we'll have a quick interview with Paul as well from Bloom, who will tell us all about the products that they do.
Hello, Paul. Welcome, and thank you very much for joining us.
Thank you very much. Thanks for having me.
That's great. Obviously, SolidCAM are very reliant on the technical partners we have, and obviously we kind of deal with the best partners we can. Bloom have been very supportive towards us with your measuring equipment and on machine measuring. I know one of the products you have is an LC50 Digilog. Can you tell us what the main features of that are, please?
Yes, Ian, I can. And thanks very much for having us today. We really appreciate it, and we really are looking forward to talking about our latest product, which is the LC Laser Control 50 Digilog. This is a new product that was launched to coincide with the 50th anniversary of Bloom in 2018. This is a next generation product that has both an analog and digital capability that captures a lot more information, 50% more quickly compared to a standard laser. The LC50 Digilog uses a new focused laser beam with 30% reduced diameter, which is optimized to ensure that the measurements being taken are more accurate and repeatable, as well as reducing the influence of coolant mist inside the machine tool. This system utilizes both a digital trigger signal to measure the cutting tool and then an analog system with around 300,000 values being taken through progressive shading of the beam. This provides a highly detailed and faster assessment of the cutting tool with nano repeatability. The LC50 Digilog also has a smart dock that has an integrated pneumatic system that enables very quick exchange of the laser for minimal downtime. The system also features a newly developed HPC high performance cleaning nozzle with 25% increased cleaning pressure to ensure no chip accumulation in the harshest of environments. In order to further enhance usability and reduce downtime, the shutter features a bayonet click mount, which makes it very quick and easy to service or replace.
That sounds really good. Is there a particular scenario where the LC50 Digilog system will be most beneficial?
There are so many scenarios that can be beneficial to end users. If you have a requirement for highly accurate and precise measurement of the cutting tool to be done with the minimal amount of downtime, as well as being very robust and straightforward to use, then the LC50 Digilog will help drive productivity and reduce wastage. This could be at a large automotive parts plant where time and minimal wastage are top priorities, or a small batch specialist CNC machine shop producing critical parts for the medical industry. The LC50 Digilog is highly flexible to service many markets.
Fantastic. Are there any particular machine requirements in order to fully integrate the LC Digilog?
Yes, in order for the laser system to be in full Digilog mode, the machine must have an Ethernet capability, Profibus, Profinet, or EtherCAT. If this is not activated, then the system will operate in digital NT mode only, checking for tool breakage. The necessary Ethernet backbone can be added by the OEM if necessary. Bloom have many years of experience retrofitting probes to machines, and we will undertake a full engineering survey of the machine prior to any installation, where we can anticipate any other requirements that are needed.
That's cool. And is there any kind of particular training and support that you offer once it's all been installed?
Yes, Bloom will fully support you from pre-sales through to installation and aftercare. We will initially provide a budgetary price for the LC50 Digilog, and then we will undertake a full engineering survey of the machine, either at the OEM or end user's premises. We will work with the customer to ensure that downtime is kept to an absolute minimum throughout the installation process. Following the installation and setup of the system, Bloom will provide full training to the operators on how to get the best from the system. We believe that this is a critical and ongoing process. Also, our engineers are fully contactable directly over the phone or email should there be any ongoing inquiries. Bloom also offers service packages to ensure that the optics are fully cleaned and functioning normally, even in the toughest of machine environments.
Sounds brilliant.
Thank you.
It's great, and I'm really appreciative of the fact that you've joined us today. And
thank you.
We are definitely looking forward to a point where we can all actually get together and do a live event together. So
I know it seems like a long time ago now, doesn't it? Since we've done anything like that.
Yeah. Okay. Well, until then, Paul, I'd just like to say thanks again, and thank you for your continued support of SolidCAM.
You're welcome. Thank you very much.
Thank you.
Thanks for that, Paul. Some really complex capabilities that Bloom have there. It's, once you start moving into the laser measurement, there's obviously a lot more features that are available. We've had a question in, Ben, while we've been talking. It just reverts back to the machine of the wing. Obviously, our 5-axis has got multiple strategies for machining, and the question has been asked as what was the name of the method or the strategy that we used to machine the wing?
So for the wing, I used the strategy morph between two curves. So I picked the wing surfaces themselves as a drive surface, and then I picked the top curve of the wing and the lower curve of the wing to blend between. So you get a nice morphing toolpath between them. You saw in the presentation there's a few different strategies. There's quite a lot of different strategies in 5-axis. One of the other ones I used was the parallel cuts. So that means you just pick one surface and you just go in parallel to the ISO lines of that surface. You can change the angle so you can come off an angle from the ISO lines as well. And the other one in there that I used as well was parallel to curve. So I picked a surface, then I picked a curve to follow. So rather than following any ISO lines or anything like that. Now at this point here, this is doing the finishing just on the above the tips of the wings, and there's just a little bit of material left where the flat bottom of the end mill couldn't get down. So I've just taken the barrel cutter in there and just nicked that out and blended it in. And this is the point now where we're barreling that face that flat face on there. So this one was parallel cuts. So we just nice clean cuts across that face. So again, you can see this is technically in 3-axis now. We've tipped over to an angle. So even though I've used a 5-axis operation, it's been as lean as it can. If it doesn't need to rotate the axes simultaneously, it doesn't have to, just because it's a 5-axis simultaneous operation. But what I've done is I've used it so that it can bank the tool over. The B-axis is constantly moving around to maintain that contact and change the contact on the side of the barrel, like I showed in the presentation.
No, thanks for that, Ben. It's you know, obviously when you get into the 5-axis, there's a lot of capabilities. And maybe this is a good time for us just to sort of have a quick chat about other things that we can do at SolidCAM. Obviously, we're a software provider, but we like to think of ourselves as a solution provider as well. We've got this great facility here, you know, a great technology center with these machines in here, and we've also got access to the best quality industry partners, and using the facilities and the partners enables us to look at specific projects for prospects and customers. This enables us to, starting from the concept, we can go through and look at the structure and the model and the strategies that are required to produce that, and we can introduce partners at various aspects of the process to be able to give us a full solution and pass that on to our customers. And obviously the machines here, when we're not doing demonstrations, they're also available for us to do trial cuts and tests for customers, and again, just kind of working through them. So we're using work holding, and we're using tooling, and obviously one of the other things that we're using is verification. So I know we've got a presentation from CG Tech VeriCut coming up shortly, but obviously we've tried to avoid any collisions on the machine, and whilst the software gives us that representation, it's always a good idea for us to check it through VeriCut and just make sure that we're not going to have any collisions.
Yeah, so as you said, it's a great collaboration between all the different partners here. So we're not only providing CAM or showing CAM, we're showing a solution right from the design. So SolidWorks, you can design the part, we can program the part, we can verify the part. We can introduce you to partners for tooling, for work holding, for probing, and everything else that you've seen today. Obviously the machine tools as well, so we can introduce you to ROMI as well. But just going back to 5-axis, there is another question. Do you have a 5-axis flank contouring, sometimes known as swarf cutting strategy? Yes, we do. So inside the 5-axis operation, for that we would use either parallel cuts, or I could use the parallel to curve, as you've seen. But we do have a dedicated swarf operation as well, just to make it easier. So you can do it in a full 5-axis operation, or we have a separate operation that uses the 5-axis in the background, but instead of it asking you for faces and things like that, it will ask you for the wall, it will ask you for the floor, and it will automatically put flank cutting or swarf machining down on the as a toolpath down on the part. You can see it's still cutting the plinth on there. Again, we're respecting the climb milling direction, so you can see that link move come across there, and now we're actually cutting when we're going in the climb mill direction. So we've got that back piece to finish there, and then we've got the sides to finish. So just before we go to the VeriCut presentation, I just want to wait for the machine to go to the bit where it does the sidewall. So just to show you that getting in access wise underneath those wings. So you can see here tipping round, and you can see I'm using the barrel cutter, so it's now not perpendicular to the upper and lower edge, and now going at an angle. It's about a 30-degree angle from that wall. And that's the beauty of using this barrel cutter. I can come in at any angle, and I can use the side of that tool to finish these flat faces and to get that nice finish on there. So as you said, Ian, we've having CG Tech as a partner and using VeriCut, we've proven all this code out through VeriCut before we put on this machine. So it's obviously an expensive machine. We want to look after it. But like I say, we've got full simulation in SolidCAM, and then as a secondary check, we put it through VeriCut, and we just verify all the code. So we'll just pass over to Tim now and have a quick presentation from VeriCut.
Hi Tim, thanks for joining us today, and thank you very much for CG Tech supporting SolidCAM in our live events. Obviously it's very important for us to be able to prove out our programs before we put them on the machine using VeriCut, so we very much appreciate that support. Obviously VeriCut as a product is continually being developed, and I believe that there's been some new developments. Could you tell us a little bit about what's coming out next?
Yeah, hi Ian. Firstly, thank you very much for this opportunity of being part of your live event. We really do appreciate, being a partner, and we have been for a long time. So we welcome that. Yeah, so we launched VeriCut version 9.1 towards the back end of June. There's obviously enhancements. Optimization, we've made that a lot more user-friendly and easier to use. Anybody can just through a few button clicks can start seeing the benefits of optimizing your existing NC code. So that's one big push for us to make it very much a package of software that anybody can pick up and run with. We've also got the multi-channel additional functionality now, so you can optimize a machine with multi-channels. We've also got the multi-tool station support on like Swiss type machines or mill turns, that sort of thing. There's annotated images, which is an enhancement to version 9, and we've also got enhancements to our AM offering. And certain subtle differences as well when you're wanting to look at the component visibility, if you like. Yeah. So that's all available to our customers now. Like I said, we launched that back end of June, so people are seeing the benefits of that already.
That's brilliant. We understand obviously that VeriCut as a product is very much involved with the blue chip industries. And has become an industry standard within sort of the big aerospace and motorsport companies. Is there something that VeriCut or CG Tech offer to kind of encourage small to medium companies to be able to gain those benefits that the blue chip companies are getting?
Yeah, absolutely, Ian. It's probably been out there. We don't promote the fact, but there's something called single platform, which is designed to enable, SMEs or people that have sort of not dared to dip their toe in the water, if you like, or they've just purchased a brand new 5-axis machine and they're a bit wary of it. We can focus on their critical machines so they can start seeing the benefits of VeriCut at a more cost effective rate, if you like, for want of a better description. Get familiar with the product, start seeing the benefits, and then you could roll it across the shop if needs be, or just focus on those 1 or 2 machines that you've got that are of a concern to you. When you're looking at you're avoiding bumps or certainly minimizing prove out on those machines to make them more effective.
Yeah, I mean that's quite an important point, isn't it? Sort of people who are investing in new 5-axis technology, obviously they need to make sure that with all these axes moving and you've got fixturing and tooling, that there are no collisions. And with the best will in the world, any CAM system will try and produce the best quality code, but VeriCut actually shows the G-code simulation, doesn't it? So rather than the actual camera platform.
Yeah. We're not looking at CL data, Ian. We're looking at the actual G-code that gets sent to the machine, and that's often where, you know, prospects pick the phone up. They've just bought that expensive 5-axis machine. They certainly don't want to have a bump on it, and you know, they want to minimise the prove out of it. They want to make it as effective as possible. So that's one of the conversations we often have, and you know, hopefully we have that conversation before somebody does have a bump, because that is another scenario that we often come across.
Yeah, I suppose if somebody does invest in a single platform, it's probably quite easy to tell them where the cost savings are going to come from. Can you just explain a little bit about where you see the main benefits and cost savings that come from using Vericut?
Yeah, without a doubt, Ian. Yeah, so you know, the main ones, if you like, avoid that prove out, avoid the person stood on the machine proving out that NC code, and obviously that's just downtime. But one biggie is obviously avoiding that bump, because we all know that if you bump a machine, irrelevant of whether it's small or big, you know, it is going to cost you a lot of money, and it's that downtime as well. You know, you've invested in that piece of equipment. You want it to be churning parts out right from the get-go.
Yeah, absolutely. Obviously, during this live event that we're doing, we will be using Vericut and proving out our program. So for now, Tim, thank you very much for joining us, and thanks again for your support.
Thanks very much, Ian. See you soon, mate.
All right, you take care. Thank you.
You too. Bye-bye.
Thanks for that, Tim. Really sorry that your heating's broken and you had to wear earmuffs. I'm sorry, won't mind me saying that. We're good friends. It's, you know, obviously CG Tech and Vericut is a very important part of what we're trying to do, because you really can't afford to have any accidents, and you know, their logo is save time, save money. You know, saving money doesn't take much when you're not crashing your machine. So we've just moved on to, I think we're on the engraving now, aren't we, Ben?
Yeah, so we're using the 1.5mm ball nose here to do some engraving on there. So we're just putting some logos on the component. So this 1.5mm ball nose is 0.1 deep in the material, 12,000 RPM, 240 millimeters a minute feed rate. So you can see it's working in 5-axis as well. So actually on that wing there, engraving the iMachining logo. So doing that in full 5-axis simultaneous mode to keep the depth consistent and it normal to that face. And then around the plinth at the bottom, we're going to have some more logos, kind of partner logos, SolidCAM logo on there as well. They'll be done in just in 3-axis because it's a flat face. So we just tip over to the angle. I have actually used the 5-axis operation to do those, even though they're in 3-axis, because what I wanted to do was tip the ball nose over, so I'm not using the center of the cutter, I'm actually using the edge of the cutter. So I put a bit of a lag angle on this cutter here, so that I'm using the edge of it rather than the center. I'm not rubbing the material off, we're actually cutting it off as well.
Okay, we've got a question, and it's reverting back to the machine. We've got a question about what the controller is on the machine.
Yeah, so the controller on this machine is the Siemens 840D. So it's pretty similar to the D1000. That's got the Siemens 828D on there. I do believe Romy offer a FANUC controller with some of their machines as well. But I think predominantly they come with the Siemens control on there. Quite a nice control to use, nice and easy, user-friendly. And as I said before, it's got the full simulation on there as well of the machine. You can see the ball nose is finished with that logo now. It's just cranked over. So you can see I'm at an angle to that plinth face there. I'm not square on at it. Tipped over, so I'm using the edge of that ball.
Does it matter to SolidCAM what the machine and the controller is?
Not particularly, no. We can create a post processor for any machine, any controller. Doesn't really matter to us. Like I say, we supply sample code and we can write the post processors for these machines and to suit any controller, really. Going back to, there's another question here with regarding SolidWorks and SolidCAM and obviously what model types it supports. So you can import models from, you can import step files, x_t files. Obviously, you can open the SolidWorks files. You can even open Inventor files in SolidWorks as well. So you can open Solid Edge files and things like that. There's all sorts of import options in SolidWorks to be able to use them in CAM. We can also cut STL models as well. So we can actually import the raw STL and just lay Toolpath down on the STL model. It doesn't take much for us to be able to do that. We have a module inside SolidCAM for that ability. Any more questions from your side? So like I say, this is just doing the engraving. Once this ball nose is finished, this part will be complete. You'll be able to see the part. I'll take the part out of the machine there, and we'll be able to see the components on there. So if you've got any more questions, just put them in the chat. Obviously, once these logos are done in the next couple of minutes, I'll show you the component, and then we'll be wrapping up the webinar. So please do get your questions in if you've got any. Does SolidCAM produce a CL file or apt source file for the post processor? So we post process the app data internally. I believe we can pull out the apt file or the source data, but we generally just process that into our post processing software, and we run that to write the post processors. There's quite a lot of information comes from SolidCAM when we're looking at a post processor. We can get any of the information that's been input into the CAM software. We can retrieve in the post side of things, so we can do lots of clever logic. We can bring lots of things in there as well. We've also got the ability to create MCOs inside SolidCAM. So inside a post processor, we can have specific MCOs for that machine that can then be used in SolidCAM and can be fully simulated as well. So, for instance, the use of maybe opening a door, for instance. So we can do an MCO where you drop an MCO in the sequence, and it will trigger the M code for the door. But we can also then implement that into the simulation, so you can see the door opening on the simulation. So we can do all sorts of things like that.
Okay, we've got a question about getting the program into the control, whether we've used Ethernet or USB.
Yeah, so in this instance, I used USB. So this machine's pretty new to us at the moment, so we've not had a chance to wire it up any other way. I put this in by running the USB in there. So, but it does have the option for Ethernet as well, so you can fully network the machine, and we can just load files across to the hard drive on the machine. And run them that way.
Is it quite a large hard drive in the machine?
Yeah, there's I think, I'm not sure, but it's in gigabytes.
Put you on the spot.
yeah, put me on the spot a little bit there. There's a hard drive in there, I think I saw 4 gigabytes, but I can't be 100% sure, but it's definitely in gigabytes. So it's quite a large hard drive. You can also drip feed the machine as well, so you can run it directly off the USB stick. If you needed to, if you had a very large program, but I don't think you would exceed the limits of the local disk on there, really.
I mean, just while this is finishing off, I know everybody's been affected by the current coronavirus issue. It might be a good point just to sort of say what we're doing as a company to try and continue our services. So at the moment we're offering online demonstrations, but as restrictions are being lifted, we're also going to start offering live demonstrations again. So if anybody's seen anything in our presentation today that they'd like to see us do live on their work, you know, we've got the appropriate PPE, we've got all the protective gear, so we're more than happy to come on site and do a live demonstration for you. Obviously, we've been doing training online as well, but I think we've almost got the factory ready for, the technology centre ready for to have trainees back in here, haven't we, Ben?
Yeah, so obviously, like I say, we've been doing remote training as it is. So it's been the exact same training with the same trainer, the same application engineer that's been running that training. We've been doing that remotely. As of August, we've prepared the tech centre now to start doing training back in our technology centre face to face. So we'll be observing all the social distancing rules. We've got things in place here to keep people safe, keep people distance. So the option's going to be there now for doing the training back in-house. And like you say, Ian, we're fully prepared to come out on site and do software demonstrations again. But again, if you prefer us to do it remote, we're happy to do it remotely still. We would prefer to come and actually sit in front of you and do a full demonstration with you, but we can quite easily do that remotely as well. As you can see, we've got all the technology here. We're doing this remotely at the moment, so it's no hard work for us to actually do the demonstration remotely either. But it'd be good to get back out on site, won't it, Ian?
Yeah, definitely. Yeah, I'm looking forward to getting back on the road again, to be honest.
Yeah, me too. So yeah, this is the last logo on there now. It's just finishing this off, and then we'll be able to see the parts completed. And we can see there it's just gone home. So I'll let you take over talking a little bit while I just
yeah, my turn to waffle. So Ben's now going to actually look like he's doing some work and move across the machine. Oh yeah, he needs a spanner as well. So he's completely prepared and left it behind the machine. So he's got to go and get it. He is going to actually take it out and hold it up to the machine camera so you can see it. I think one thing to point out is that for the purpose of the demonstration, what we've aimed to do is to show you a finished part, and we've maybe not taken as fine a cut as we could have done on the ball nose area, so on the tail part of the model. So when you see it, you probably will see some machining marks, but I think the biggest point is, there you go, you can see it there. The biggest thing we wanted to show today was that by using barrel cutters and being able to take kind of a 2.5 mil step down, you're achieving the same finish as if you were taking a 0.1 step with a ball nose cutter. So there we go with the logos on as well. So great looking part, mate.
Yeah, so as you can see, the part's finished there. We'll switch to the main shot of us now. So that's the part complete. You can see the finish on there. Like Ian says, I did a large step over with the ball nose just to save a bit of time on this webinar. So the finish is not at its best on that there, but we wanted to demonstrate the barrel cutting and the finish you can get with the barrel cutters rather than using the ball nose on there. So yeah, so I think I hope you've enjoyed the demonstration. I hope you've all got something out of it as well. Like I say, if you've got any more questions, feel free to contact us. We'll be happy to answer any more questions and help you out. If anybody does want a demonstration, then please let us know.
Do you want to mention part 2?
Yeah, so we've got part 2 coming up as well. So this was part 1. We've got 5-axis part 2 coming up, which is on the 28th. There'll be a new link being sent out. Everybody that's registered for this presentation today will be sent out a link for the next presentation on the 28th. We'll be using this machine, so we'll be using the DCM 620. We'll be using simultaneous 5-axis. Show some different techniques. We'll be barrel cutting again, and again we'll be showing eye machining and the benefits of that. So I hope you can all join us for that next event. But for now, I'll hand over to you to close off, Ian. Thanks very much.
Say thank you. If there was a little bit of a technical issue here, seeing if we can address that.